For next 1 hour or so, we will be discussing about non-destructive techniques for pavement evaluation. Uh, road sector, I guess all of you know that the road sector is one of the fastest growing fields in India. Uh, the total road network in India is more than 5.5 million kilometers, of course, which includes all the national highways, state highways, major district roads, urban roads, and rural roads. Uh, and the national highway construction is at a pace of 34 kilometers per day on an average in the last financial year. Why am I saying is that there is a huge scope of employment in the field of payments. I'm not just talking about the skilled employment. I'm also saying that both skilled and unskilled employment, there is so much of scope. Okay, let's begin and we'll see what we have got in this webinar session. So these are my contents. First, I will give you a brief introduction about the payment. I presume that all of you are civil engineers. Still, the payment is a specialized part of civil engineering. So I'll just give you a brief introduction to keep us everyone on the same page, and to I will also try to keep my presentation as simple and basic as possible, because everyone will easily understand the next complex topics. And we will also see what are the requirements of the payment and what are the parameters that need to be evaluated for a payment. And finally, we will see how we have to do the functional evaluation, how we can do the structural evaluation. And finally, we will see what are the job opportunities we've got in this field. I must say that especially this payment evaluation or non-destructive techniques for payment evaluation is not just for civil engineers. We are using some techniques which involves lasers, which involves some sensors, some high-end instrumentation, as well as some good softwares. So there is a scope for, of course, it is a branch of civil engineering, but there is a scope for all engineers in this. We have got some very good slides coming ahead, and we will see. Let's start with what is a pavement first. I know all of you are civil engineers, and the the common word used for a civil engineer is structure, right? A building is a structure, a bridge is a structure, a dam is a structure. So similarly, pavement is also a structure, and every structure will be designed to carry a specific load. For example, if you take a building, it is designed to carry the dead load and live load, and the load from the slab is transferred to the beams, beams to columns, columns to the foundation. Similarly, the pavement has also got some load to bear. So pavement is a structure that is built to carry the vehicular loading. The load here comes from the vehicles. So basically, the load from the vehicles is transferred to the axle of the vehicle. From the axle, it will be transferred to the wheels. And from the wheels, it will be transferred to the road surface. So there is a interaction point for a tire or for a wheel and the surface of the road. And through that point, the load will be transferred to the pavement. So from the pavement, it will ultimately go to the foundation. So similarly, pavement also got some foundation. And mind you, the pavement is a layered structure. We have got different layers in the pavement. And specifically, they will be called as surface course, base course, and sub-base course. Of course, it will be varied from type to type of a pavement. And there are different types of payment. I will not be discussing all the types of payments, but the basic or the major type of payments we use in India are flexible payments and rigid payments. With the name itself, you can understand what is a flexible payment and rigid payment. Specifically, flexible payments are made up of, asphalt, aggregates, and fillers, whereas the rigid pavements are made up of concrete or cement, aggregates, water, and sand. So, uh, generally, we call flexible pavements as bitumen roads, asphalt roads, BT road, tar road, some places, and rigid pavements are called as cement roads, CC roads. This is about the payment. Now, what are the requirements of a payment? What do we expect from a payment? What we want from a payment? There are basically all the requirements are basically categorized into two types, either to the functional or to the structural. So let us see what is the functional requirement, what is the structural requirement. We will start with the functional. So I want my payment to be comfortable. When I'm going from point A to point B, I want my journey to be comfortable. I want a smooth journey. So this is the functional requirement. I want to go fast as possible. When I'm saying fast, and I don't want to compromise my safety, right? So I want to go as fast as possible from point A to point B, and at the same time it should be comfortable. This is my one of my functional requirements. And if you see, the second functional requirement is that the my total vehicle operating cost should be as less as possible. So I think all of you know, the vehicle operating cost, the major component is the fuel. So if your road is not good, if your road has so many potholes, or if your road is uh, you know has some raveling or rutting, any distresses, obviously the you have to slow down the vehicle, you have to accelerate and decelerate so many times. It will ultimately affect the fuel consumption, right? So this is how it affects the vehicle operating cost. uh, I believe every one of us wants to give our vehicle to give more, mileage or average, so that less fuel will be consumed. This is one of the functional requirement. And the third most important thing is the safety. So I want my journey to be safe. When I'm going from point A to point B, I want it as safe as possible. This also comes into the functional requirement. So as a user, and now I'm talking in terms of a user, I'm not an engineer or anyone. Everyone in India or everyone in the country is a user of a road. As a user, I'll just see that the road which I'm using is to be functionally good. Whereas if you see the structural part, what are the structural requirements of the pavement is that it should have adequate pavement thickness. If you don't have adequate pavement thickness, it is going to be failed fastly than it is anticipated. And other thing is that it should have uh, enough strength to bear the different magnitude of loads. So if it does not have enough strength, there may be chances that it will be going to fail prematurely, and it will ultimately affect the functional performance. So as an engineer, as a maintenance engineer or a highway engineer or highway design engineer, I'm more concerned about the structural requirement of the pavement. When I'm designing a pavement, I will see that my pavement is having the enough thickness, and I also see that it will be having enough strength to bear the load. So as a engineer, I will be more concerned about the structural requirement. As a user, or as a normal citizen of India, you are more concerned about the functional requirement of the pavement. Now we will see what are the parameters that need to be evaluated for any pavement. Again, if you see the structure here, all the parameters are divided into two categories. Either it comes into the functional parameter or the structural parameter. And if you remember the functional requirements, I am talking about the comfort, I'm talking about the safety, I'm talking about the low fuel consumption or low vehicle operating cost. So how do we evaluate them? So the first parameter that we evaluate is roughness. The roughness is a parameter that is used to measure the comfort of your journey. the riding quality of your journey. So we will talk about this in detail in the next slides, but roughness is basically the parameter to measure the comfort of your journey. So if your roughness is very high, so the journey is not smooth, it is bumpy. And if your roughness is less, your journey is smooth. So this is one parameter. And the next one is the skid resistance. So when I'm saying the safety, so it comes under the skid resistance. So if your skid resistance of the road is good, it is high, then it is more safe. If the skid resistance is very less, and we can say that the road is not very safe. So it basically a parameter of friction between the tire and your pavement. So if the friction is less, there may be high chances that the vehicle will be skidding and will be and there will be chances of crash. And the third parameter is distresses. So distresses is not a small term. Just to fit in here, I've shown you three types of distresses, but mind you, there are 17 distresses for flexible payment and 16 distresses for rigid payment. For all of you, all of them may be not very uh, useful or concerned, but there are 17 distresses and we will be measuring whatever as per our requirements. We have to evaluate them. So for example, you have cracking, you need to measure what is the area of my pavement is cracked. And if you are measuring the raveling, what is the area of my pavement is raveled. And for rutting, what is the uh, what is the depth of rut, what is the length depth of rutting happened on a road. Or if you have a potholes, it will be measured in terms of number, how many number of potholes you have from point A to point B. So this is how we will do the functional evaluation. As I said, functional evaluation is the reflection of the user perspective. And if you say the distresses, if the distresses are very high, there is a good chances that the vehicle fuel consumption or the vehicle operating cost goes high. So everything is interlinked. And the next important parameter is in terms of structural point of view. So the structural evaluation is done, and of course we will measure the thickness, but the thickness is not a time dependent parameter. The time dependent parameters in terms of structural point of view is the strength. So as the time goes on, as the life of the pavement goes on, there may be chances that the strength of the pavement will goes on decreasing, right? Because of the continuous application of the load. So we need to evaluate what is the strength or what is the remaining strength to assess the uh, capacity of the road or assess the load bearing capacity of the road. So other than this, we also have some parameters which are equally important but may not be evaluated every time. So the other factors are like drainage of the road, how good is the drainage condition, and also we will see what is the type of material we are using, whether it is economical or not, because sometimes we may use some materials which are very good in quality and we will use a very high thickness of pavement, but the actual traffic is very low. So it is not actually economical. It may be safe, it may be strong enough to bear the load, but it is not economical. So we have to take care of that as well. And also we should see the maintenance should be as less as possible. We cannot go for very high maintenance roads. So these are the parameters. And now we will see uh, what are the what how can we do the functional evaluation. So I hope you all remember what are the parameters in the functional evaluation. First one is roughness, second one is the distresses, third one is the skid resistance. These are the three main important parameters that we will be doing in functional evaluation. Okay, so you are seeing one of the state-of-art facilities which will cover most of the functional parameters. It is called as automated road survey system. This system is used to do the functional evaluation in a non-destructive way, and it will cover most of the parameters that are concerned with the structural evaluation. Right? If you see the different, basically automated road survey system is an integration of different technologies, and it is combined together to use so that most of the parameters will be evaluated all together. So if you see the different if you see the different equipment here, we have digital cameras. These are very high definition digital cameras. We have auto crack detection systems, or sometimes we use it, even we detect the cracks by using the cameras. And we have the GPS. There is a setup called Gypsy Track, which is a combination of different sensors like accelerometer and gyroscope, which is, help you to capture the geometric parameters of a road. And we also have the distance measuring device, which will actually measure the distance, longitudinal distance. And we have the mobile line reflectivity, which will help you to assess the performance of the pavement markings. And there is a digital laser profiler. This is used to measure the roughness. We will talk about them in detail in the next slides. So, and finally, we have one data acquisition system. So what we can actually do with the automated road survey system? Actually, automated road survey system has got many names. Few people call it as network survey vehicle. Few people will call it as traffic speed survey system. And in few countries, in India, we call it as automated road survey system. So the advantage of this system is that we can do the survey up to 100 kilometers per hour. So all you need is to sit in the vehicle and switch on all the systems, and it will collect the data for you. And you have to do some post-processing data analysis, and ultimately you can get the actual functional data of a pavement. So what it will give you more is, it will give you the longitudinal profiling. Longitudinal profiling is nothing but the roughness parameter. It is measured in terms of International Roughness Index. And we will also get the transverse profiling. It will give you the rut depth. So these will be measured in conforming to the ASTM standards. And it will also give you the mean profile depth or the mean texture depth, which is a parameter of a skid resistance or the friction. And it will also give you the cross slope, gradient, and horizontal curvature. It is the geometric parameters of a road. And you can also map the network where you are doing the survey by using the GPS or DGPS system. So you no need to remember where you are doing the survey. It will automatically map it. You will get in a Google Maps that at the end of the day, you can just check, okay, I have done the survey from point A to point B, and this is the location, this is the place where I've done the survey. So no need to remember or note where you are doing the survey. And the cameras will be help you to capture the surface imaging, and this will help you to assess the total distresses on the pavement. And we also have the video camera to assess the roadside furniture, or you to capture what are the assets in my road. And finally, we have one data acquisition software for data collection and to display all the data and check the data at the site itself. And there is a post-processing software which help you to data analysis and also for the preparation of the reports. This is the functions of the automated road survey system. And we will see how we actually measure the roughness with this automated road survey system. So we will measure in terms of International Roughness Index. And there is also another parameter or other unit called roughness index. There are some other equipments which we measure in terms of roughness index, but the laser profilometer attached to the automated road survey system, we will measure it in terms of international roughness index. If you clearly see the units, you can yourself understand what is this roughness about. The units are millimeter per kilometer and meter per kilometer. So basically, roughness is the amount of vertical movement per unit length of kilometer. So the more is the vertical movement of your profile or the road, so the more will be the roughness. So the more will be the roughness, you will have the less riding quality. That is basically about the roughness index. And as I said, there is something called laser profilometer attached to this automated road survey system to the front of it. It is projected like a beam, and it is called digital laser profiler. And what it contains is, it contains number of lasers, it contains some sensors called accelerometer, it contains some sensor called gyroscope, and using this combination, it will continuously emit lasers. So, and it will measure the time that the laser has taken to come back. So it is a simple time and length principle, where it will measure the time taken by the laser, and if the time taken to come back is more than the actual time, so we can say there is some pothole, or there is some there is some kind of um distress is there at the payment. And if the time taken is less than the actual time, then we can easily imagine that there may be some speed breaker, or there may be some bump at that place. So based upon this, it will actually give you the original profile of the road. It will give you the complete transverse profile of the road. So whenever there is a noise due to vehicle uh, vehicle suspension system, the accelerometers will be canceling that noise to give you the actual profile. This is the function of laser profilometer. And we have another set of lasers called transverse rut scanners. These will give you to capture the transverse profile of the road. So transverse profile basically gives you the rutting parameter, like rutting depth. What is the depth of my rut? If you see the picture here, this is the actual ARS system, which how it looks like. This is acquired by the government of Karnataka, of course. It contains different cameras, one facing towards the pavement, few facing towards the front, uh, and there are rut scanners, and there are so many sensors inside this system. And of course, on the front of this, you can see the laser profilometer. This is how the network survey vehicle looks like in actual. So as I said, this rut scanners will help you to capture the rut depth. So there are two rut scanners attached to the backside, which will be continuously emitting the lasers. There will be the transmitters and the receivers, and it will actually, you can measure 640 points across the 4 meters of road. So you can imagine what will be the frequency and what will be the distance between each point, and how true profile or how true transverse profile you will be getting by using this rut scanners. These are again laser based rut scanners, and it will give you the actual profile. So rutting is basically the deflection on the wheel path. So it will be captured by using the transverse profile, right? So this transverse profile will be captured by using these rut scanners. And the other parameter which we capture is that the geometry of the road. Whenever we are doing survey, we also want what is the geometry at that particular road, what is the gradient, what is the cross slope or camber, what is the curvature at that point, and how much rise and fall is there on that particular pavement. all these will be captured by using this Gypsy Track, something called Gypsy Track. I've already told you that Gypsy Track is a combination of gyroscopes and accelerometers. So these are the sensors basically present in the aircraft. For maneuvering of the aircrafts, they will be using this sensors. So the same sensors are used in this automated road survey system, and it will measure whenever there is, for example, when you are negotiating a curve, your vehicle will not be in the straight position, so it will bend somewhat. So this bending will be captured by using the gyroscope, and it will give you what is my camber, what is the cross slope of this place, and it will also give you what is my gradient when the movement is towards the front, or when there is a longitudinal movement, it will gives you the radiant. When there is a transverse movement, it will give you the cross slope. At the same time, accelerometer will give you what is my horizontal curvature, means how much degree per kilometer you are the curvature is. That is also measured by using this uh, accelerometer and gyroscope. And the most important thing is the how we will capture the distresses. So till now we have only seen the distresses of rutting. One of the distresses is rutting, that is captured by rut scanners, but there are several other distresses, like we have cracking, we have raveling, potholes, shoving, edge break. There are a number of distresses. So how we can actually capture this? So if you see the network survey vehicles, there will be some cameras which are facing towards the pavement. They are very, very high definition or high resolution cameras that will continuously capture the pavement images. In fact, it will capture the video of the pavement, and it will divide it into the different frames of the pavement, 3.5 to 4 meters actually. Then using the post processing software, we will we will quantify how much cracking is there, how much raveling is there, or how many number of potholes we have. So we will quantify by using the post processing software. Basically, this post processing software will use some machine learning algorithms as well as the image processing techniques. By using these two techniques, it will automatically both identify and quantify that all the type of distresses, and it will give you in a spreadsheet, it will give you in an Excel sheet that for this road for 1 kilometer, what is my area of cracking, what is the area of raveling, how many number of potholes are there. All these details will be given, generated in terms of reports.